How do we solve for the reaction forces on a simply supported beam? Let's start with drawing a free body diagram. Simply supported beams have a pin support on one side, which can provide reaction forces in both the horizontal and the vertical directions. And at the other end is a roller support, which can only provide reaction forces in the vertical direction. For our load, we'll apply a point load at some length along the beam and at some angle to the beam, so that a portion of the load is in the horizontal direction and a portion is in the vertical direction. This is our most general loading case for a simply supported beam, and if we can solve for the reactions in this situation, then we'll be able to solve for the reaction forces in any loading situation. The supports for our beam have to keep our beam from moving and from rotating, and for that to be true, the sum of the forces in the x direction, the sum of the forces in the y direction, and the sum of the moments acting on the beam all have to equal 0. So our goal is to find the reaction forces that make those three statements true. Let's start by solving for R1x. This will be the easiest one to solve for because there are only two forces in this situation that act in the horizontal direction, R1x and P sub x. For the sum of the forces in the x direction to equal 0, these two forces have to be equal in magnitude and opposite in direction. So R1x has to be equal to P sub x. That solves for one of our reactions. Next, let's solve for R1y. To do this, we'll sum moments about reaction 2. Now, why sum moments about reaction 2 for this? It's because a lot of our forces have lines of action that pass through reaction 2, so that they don't create a moment about that point. This makes the math easier to handle. So R1x, P sub x, and R2y don't create a moment about reaction 2, so that leaves us with R1y times the length of the beam, L, and that'll be a negative moment according to the right-hand rule, and P sub y times B, which will be a positive moment according to the right-hand rule. If we set those two equal to 0 and then solve for R1y, we find that R1y has to be equal to P sub y times B divided by L. So that's the second of our two reaction forces. For R2y, we can actually just mirror what we did with R1y, solving for some of the moments about reaction 1 instead of reaction 2. With that, R1y becomes R2y, B becomes A, and we have all three of our reaction forces for a simply supported beam.